Today we're going to learn how to calculate the area of a rhombus, and like everybody to open up their exercise book, write the date, write the heading area of a rhombus, take your time and do it neatly please. Now what I'm going to do is to draw a rhombus. Please use a ruler when you're doing this. Now a rhombus has four sides that have equal length. It kind of looks a little bit like a parallelogram that has fixed length sides, or the other way you can think about this is a square that has been squeezed in from both ends, so that it is now no longer right angled inside the shape. Okay, so I have drawn a rhombus, and I'm also going to put little strokes like this on all the sides. That is going to indicate that all sides of a rhombus are equal in length. Now I'm going to draw in the diagonals. So this is the first diagonal. And I'm going to switch color, and I will use blue. So these are my two diagonals, and I'm color coding so that I can make my diagram a little bit more clearer. So this particular diagonal here, so the same length as that, I'll just indicate outside that I'm going to call it X. Okay, so X is the length of this diagonal, and then using my blue color I'm going to draw a line here. So that line is the same length as that dotted diagonal, and this will have a length of Y. Now I'm going to do a little bit of transformation to show you how everything is going to work. We can actually trace back all shapes to a rectangle. Okay, so really if you're calculating the area of a special quadrilateral, the only formula you need to really remember is a rectangle, and I'll show you why. Now because all sides are equal, these two diagonals intersect at right angles. Okay, so there are right angles here, 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 and here. So what that's telling you, and you can see it very clearly, is that you have four triangles that are the exact same size and shape. So I can take this triangle here, cut that out, and I can move it to this side and put that triangle here. Similarly, I can take this triangle and I'll cut that out, spin it around and attach it onto this side. And now you can see that once you have taken these pieces and put them on the other side, you have now got a rectangle. So I have rearranged the pieces of a rhombus to form a rectangle. And we all know what the formula for the area of a rectangle is, and that's just length times width. Okay, so let's write this down. The area of a rhombus, we have turned it into a rectangle, and the length of the rectangle is Y. The width of this new rectangle is only half the length of X. So as a formula, we can write down that it is half of x times y. Okay, so this is width and that is length. If you want to visualize that as a rectangle. Okay, so some of you might say, is there another way to rearrange this rhombus so that it doesn't look like this thin, long rectangle? And the answer is yes, you can rearrange it into a different looking rectangle. So I'm going to draw this rhombus again. And I will show you another way that you can rearrange it. Now you don't have to copy this version, you just have to copy the top version. And as long as you understand where I'm coming from, that is fine. So what I'm going to do this time, and that's going to intersect at right angles. What I'm going to do this time is to take this triangle here, and I'm going to turn it around and put it over here. So it's going to look like this. And I'm also going to take this triangle and spin it around, and it's going to look like this. So once again, you have made a rectangle, but it's not the thin, long one that you saw in the first instance. It's now a fatter and shorter one. And if we still have our diagonals labeled as x and y, then this time you can see that we are writing it a little bit differently. So our formula then becomes half of, now let's look at that, covering that up because you have now taken the triangle over to the other side. In this rectangle, the new width becomes half of y. So we've got half of y. And the length of that rectangle is still all of this diagonal, which is x. Okay, so this is your width of the rectangle, and that is your length. And you can see that if you compare these two versions, they give us the area of the same rhombus, but they used a slightly different formula by the looks of it. But in fact, what that's telling you is that it doesn't matter which diagonal you assign as your x and your y, as long as you're multiplying all these numbers together, it is going to give you the correct answer. So when you look at a picture of a rhombus, just take down what the two diagonals are, multiply them together along with half, and you should get your answer. Don't worry so much as to assign which one x is and which one y is, because it doesn't really matter when it comes down to finding the answer.